So here we are in part 2 of adding and subtracting fractions, where we are going to see what we do when the denominators don't match. So in every example we did in the first video, the denominators were already the same as each other, which means we had taken our pizzas and we had cut them into the same number of sizes of pieces, and it was easy enough to add them together. But what happens if we have a pizza cut into sixths and another pizza cut into twelfths, and somebody eats 5 pieces of the one and somebody eats 5 pieces of the other? How much pizza have we eaten? What is 5/6 of a pizza plus 5/12 of a pizza, is that first question there. And what we need to do, we can't do anything with adding or subtracting fractions until those bottoms are the same as each other. Now, everything on this first page, yeah, we can't add because they don't have the same denominator. Everything on this first page, we're going to do this in stages. All 3 of these examples here, well, actually, no, just the first 2, have this. I've set up very carefully so that you'll notice that one denominator goes into the other. 6 times 2 equals 12, right? 6 goes into 12. So if I just take that first fraction and I double the top and the bottom, which I know I'm allowed to do, it'll be the same fraction. That gets me 10/12 plus 5/12, and just like that, I have made this so that I can add those fractions together. So now it's just like the ones we did in the prior slides. 10/12 plus 5/12 is 15/12. Divide the top and the bottom by 3 to reduce it, and I get 5/4. So you see, just with a quick little maneuver here, we had denominators that did not match. We made them match. And what I should really do is throw a visual here, in a picture here with a pizza with 5 out of 6 pieces of a pizza, showing that it is exactly the same as 10 out of 12 pieces of a pizza. We did that the other day with similar examples, but that would help drive that point home. I'll try to add that in for next time. And again, either as an improper fraction or as a mixed number, depending what the question wants. This next one over here, same problem. We see that the denominators do match, but same solution, because we notice that if we go 3 times 5, it will become 15. So if I can make this denominator 15, then we'll be in business. I can do that by multiplying both the top and the bottom. So an easy solution, since 3 times 5 equals 15. So I'm going to take the top and the bottom of that second fraction, multiply them by 5. And just like that, I now have a common denominator. 11/15 plus 10/15. The denominators stay the same, and I get 21/15. I always check to see if it reduces, and I notice that 3 goes into both the top and the bottom, so I will do that, leaving me with 7/5. That's an improper fraction, or as a mixed number, 5 goes into 7 one time with 2 left over. Okay, now we get into the ones that are a little bit more involved. Sorry, my talking is not good right now. So the denominators do not match, 6 and a 9. So we have a problem. And unlike these two, we can't just go 6 times something is 9, because that's not going to work. So what we have to do here, I think I'm going to, same problem, but worse, since 6 does not go into 9, right? So I'm going to take this problem onto an empty slide so we have a little bit more room to work on it. And here's what we need to do. We need to find something that both 6 and 9 go into, so that we can make both of the denominators that same thing. Preferably, we want the smallest thing that they both go into. We could just go 6 times 9 is 54. 6 and 9 both go into 54. That's true, but that's going to make the numbers a lot bigger than we want them. So here's where we come back to that whole lowest common multiple thing. And in this case, it's the exact same, literally the same thing, but we call it the lowest common denominator because we're talking about two denominators of fractions. There's a lot of words here. LCM, lowest common denominator. It's as simple as this. We want the smallest number that 6 and 9 both go into so that we can convert these fractions to things that can be added. So we list off the multiples of 9, 18, 27, 36, 45, and so on. We can keep going if we need to. We list off the multiples of 6, and we notice, I should have put those in red. I'm going to create a new slide. I'm going to put those in red. We notice that there. Both 6 and 9, the first number that they both go into is 18. So that is the lowest common denominator when the denominators are 6 and 9. So we're going to force both of the denominators to be the same by making them both 18. And here's how I like to do this. People often try to start this. This is my biggest piece of advice on adding and subtracting fractions right here. People will just start to try to write from the start of this next line right here. They'll try to write the top and they're immediately stuck because they don't know how to get the top. Follow these steps. Rewrite the entire addition, but with the denominator that you want to have, 18, and nothing on the tops. And then go through fraction by fraction and figure out what the top should be. So in order to make this first denominator, in order to make that 6 into an 18, I had to multiply by 3. So I multiply the bottom by 3 and the top by 3, which gives me 3 over 18. In order to make this second denominator an 18, I had to multiply 9 by 2 to get 18. So I do it. Multiply the bottom by 2 and the top by 2. And I get 5 times 2 is 10. And there, I have turned 1/6 into an equivalent fraction, 3/18, and 5/9 into an equivalent fraction, 10/18. I now have matching denominators, which means I can now add the tops. 3 plus 10 is 13 over 18. This one doesn't reduce, so I'm done. There's nothing that goes into both 13 and 18. It's not an improper fraction, so there's no second option. That is my answer right there, 13/18. Okay, so here's the process. If you're a process person, and you can screenshot this if you want, check if one of the denominators divides evenly into the other. If so, just multiply the top and bottom of the lower one to get the higher one. Okay, that's a lot of words. Let's go back and look at what that means in an example. Backtracking here all the way to this. That's like these first two examples where we said, oh, hey, I can just go 3 times 5 is 15, right? One of the denominators, 3, goes into the other denominator, 15. So you just multiply that fraction top and bottom to make the denominators match, and you are in business, okay? So that is the first thing you want to look for. Don't start trying to find a lowest common denominator if you notice that one of them divides evenly into the other. If that fails, step 2, then you need to find the lowest common denominator, in other words, the LCM of the two denominators, the smallest number they both go into. And then you adjust each fraction by whatever number is necessary to make it have the lowest common denominator. So there, if you want to screenshot that probably doesn't make sense just reading it like that, but if you have that sort of to look at as you try examples, I think it's helpful. So 1/4 plus 5/6, so we immediately see we want to add fractions, but they do not have the same denominator. That's a problem. Does one of them go evenly into the other? Because that would be the easiest solution. No, 4 does not go evenly into 6. Okay, so we have to do the hard way. We have to find the LCM of 4 and 6. So we list off our multiples of 4. 4, 8, 12, 16, 20, and so on. List off our multiples of 6, and we spot that both 4 and 6 go evenly into 12. So my goal is to make both denominators 12. And look how I do this. I rewrite my entire next step with the denominators of 12 and nothing on the top yet. And that helps me set up what my next step of work is going to look like. Now I do them one at a time. What did I multiply the 4 by to get 12? I had to go 4 times 3 to get 12. So that's what I do to the top and bottom of the first fraction. 4 times 3 is 12 on the bottom. 1 times 3 is 3 on the top. What did I have to do in the second fraction? To get 6 to turn into 12, I had to multiply by 2. So that's what I do to the second fraction. Multiply top and bottom by 2. 6 times 2 is 12. 5 times 2 is 10. Now I have created the same denominator in both. These are equivalent fractions and equivalent fractions. So it's the same two things being added, just now they both have the same denominator. And there's my answer, 13 over 12. Read the instructions carefully. Do they want an improper fraction, or do they want a mixed number, 1 and 1/12? Same thing over on this one, a 5 and an 8. Does 5 go evenly into 8? No, it doesn't. So there's no easy way, quick way to do this. So I list off my multiples of 8. And this one's a little bit easier. Look how I did this. I'm not even going to bother listing my multiples of 5 because I know 5 goes into anything that ends in a 0 or a 5, right? 10, 15, 20, and so on. So I just list off my multiples of 8, 16, 24, 32. Oh, there's one that ends in a 0 or a 5 there. So that's going to be my LCM without even going any further. 40 is the first one divisible by 5, so that's what we're looking for. We're going to make both denominators into 40. Look at how I set up my entire next step of work there by rewriting the fraction subtraction, but making both my denominators what I want them to become. Now I ask myself, in the first fraction, what did I do? I multiplied 5 times what to get 40? 5 times 8 makes 40. So I multiply the top and bottom of the first fraction by 8 because that gives me 24 over 40. 3 times 8 is 24. In the second fraction, what did I multiply the 8 by to get 40? I had to multiply by 5, so that's what I do in the second fraction. 1 times 5 is 5, 8 times 5 is 40. I have now converted this question that I could not subtract into one where the denominators are the same. 24 minus 5 is 19. I'm going to pause and mention something really important before we carry on. And that is, a lot of people, we get into the adding and subtracting, they figure out how to find the common denominator and rewrite the fractions, and then they go back to a multiplying and dividing question, and they start turning everything into common denominators. You do not need common denominators for multiplying and dividing fractions. I'm going to add a slide in here somewhere that says that. I'm going to do it right here. I'm going to do it while I record. You need a common denominator to add and subtract fractions. When you are multiplying and dividing fractions, do not find common denominators. It's not wrong. It will make the numbers unnecessarily big. You're going to make all your numbers bigger for no reason at all. When you're multiplying and dividing fractions, you do not need common denominators. You do not need to have both fractions have both in eighths or both in tenths or both in 15ths. They can just be whatever they are, just like we did on Monday. and you multiply them, you divide them. Only for adding and subtracting do you need to find common denominators. Okay, let's carry on. A few more notes, or a few more lowest common denominator tips. Right. When you're listing the multiples, start with the bigger number until you see something that the smaller number goes into. Often you don't need to list all the multiples of both numbers. Just list the multiples of the bigger number until you spot something. Oh, there's something that 3 goes into, or oh, there's something that 5 goes into. And that often can save you a bit of time. So for example, with 12 and 9, let's say you know your 9 times table pretty well, right? 9 has a little trick, right? All the 9 multiples, the two numbers add up to 9. 12, does 9 go into 12? No. Does 9 go into 24? No. Does 9 go into 36? Yes, there we go. I got it, right? So just list your multiples of 12 without listing all your multiples of 9. If you ever notice that the two denominators have no common factors, in other words, there's nothing that goes into both of them, then you can skip all of the listing multiples. The lowest common denominator will just be the 2 multiplied together. So 14 and 5, there is nothing that goes into both 14 and 5. 2 goes into 14 but not 5. 5 goes into 5 but not 14. Other than 1, of course, goes into both of them. Other than that, there's no common factors. Therefore, you don't need to list a whole bunch of multiples. You already know for a fact the lowest common multiple will be 14 times 5 is 70, because they have nothing in common. And I've double checked that here by listing multiples. There's all the multiples of 14. There's all the multiples of 5. Sure enough, 70 is the first one. That's not always the case. It's only if they have nothing in common. Nothing divides evenly into both of them. If you don't get the lowest common denominator by accident, you get a higher one. If you don't get the best one, it's all right. You're just going to get some bigger numbers and you have to do some reducing in your final step, but it's not the end of the world. So let me show you what happens here with that. So let's say we do 5/8 minus 1/6. Now the lowest common denominator for 8 and 6, the smallest number that 8 and 6 both go into, is actually 24. But let's say you didn't notice that and you found 48. Yeah, there's proving that 24 is the lowest. The multiples of 6, right, and the multiples of 8, they both go into 24. They also both go into 48. Let's say you missed the 24 somehow, or you just multiplied them together. Wouldn't recommend it, but say you get confused and you use a 48. Watch what happens. It's totally fine. So I'm going to make both denominators into 48. So I write my next step of work there. I ask myself, what did I do to the 8 to get 48? And again, times table is absolutely invaluable. I multiplied 8 times 6. So I do the same thing to the top and get 30. Then I ask myself, what did I do to the 6 to get 48? I multiplied by 8. So I do the same thing to the top and bottom, multiply by 8. 1 times 8 is 8. And now I subtract. 30 minus 8 is 22. I notice that I can reduce this fraction because the top and bottom are both even, so I divide top and bottom by 2. 22 divided by 2 is 11. 48 divided by 2 is 24. And there's my answer. So this is the same answer you would have gotten if you had used 24 instead of 48. All that would have happened is instead of getting this step and having divide top and bottom by 2, you would have gotten straight to 11 over 24 as your answer. So you're still going to get the right answer. All right, let's take a look at these examples that you hopefully just took a few moments to try. So there on this first one, we see the denominators do not match yet, but we notice that we can do this one the fast way because 10 goes into 30 evenly 3 times. So I'm going to take that first fraction and I'm going to make its denominator 30 as well, so that you can see we will now have both denominators be 30. We're going to do that by multiplying the top and bottom of just the first fraction by 3, which will create an equivalent fraction of 21 over 30. And now we have matching denominators, so we can add the tops together and keep the denominator the same. And that's going to give us 30 over 30. We would never leave our answer like that because 30 over 30 is simply 1. And again, we can, well, no, never mind. We'll skip the pizza analogy this time. 9/10 minus 5/8, the bottoms do not match. And we can't do this one the fast way because 8 does not go evenly into 10. So we're going to have to find the lowest common denominator for 10 and 8. And if we listed off the multiples, you would find that it's 40. You can do that one also pretty quick like we did the other one. Just list off the 8s until you get to one that ends in 0, right? Because 10 will only go into things that end in 0. So we're going to make both of the denominators 40 and then figure out what goes on top, right? Remember, write this step out. So many people will they stall once they figure out the 40 and then they don't know what to do. Write out the whole next step without the tops on. It makes a world of difference. So what did I do to the 10 to get 40? I had to multiply by 4. So I do the same thing to top and bottom of that fraction. 10 times 4 on the bottom is 40. 9 times 4 on the top is 36. What did I do to the 8 to get 40? I must have multiplied by 5. Again, you can find that by going along your 8 row in your times table very quickly. 8 times 5 is 40. 5 times 5 is 25. I now have matching denominators, so the bottom stays the same, and the top becomes 36 minus 25, which is 11. And there is nothing common, nothing divides into both the top and bottom, so that answer is done. Over here, I gave the suggestion that you want to turn these into improper fractions, and I'll talk about why we did that as the very last thing here in a minute. So 2 times 3 plus 1 is 7, so 2 1/3 is the same as 7 over 3. 1 times 5 is 5, plus 4 is 9. 9 over 5. Now we see we don't have a matching denominator. We have to find the lowest common denominator. And hopefully we notice that 3 and 5 have nothing in common. There's nothing that divides into both of them. Therefore, we can use our other little trick that the lowest common multiple of 3 and 5 is simply going to be 3 times 5, 15. Again, because they have nothing else in common. Look back over here, the lowest common denominator of 8 and 10 was not 80, it was 40, and that's because 8 and 10 do have things in common. 2 goes into both of them. Okay, so we're going to turn both the denominators into 15. What did I multiply 3 by to get 15? I multiplied by 5, so I do the same thing to the top. 35. What did I multiply 5 by to get 15? I multiplied by 3, so I do top and bottom times 3. Gives me the 15 on the bottom that I want and a 27 on the top. I now have common denominators, so I can subtract the tops. 35 minus 27 gives me 8. 8/15 is my final answer. That does not reduce. It's not an improper fraction, so there's no mixed number option. That's just what it is right there. Okay, I've been promising that we're going to look at this situation where subtracting by pulling apart the mixed the whole number and the fraction causes a bit of a hassle. And I don't know if anyone can guess just by looking at that why I recommended on this one going to improper fractions rather than pulling it apart like we did on earlier ones in the last video. Let you think about that for a second. So let's try it. So I've got in red the whole numbers and in blue the fractions. I'm going to split them apart. I'm going to do them separately. And let's just go look at this fraction bit first before we do 2 minus 1. So we got, again, we need a common denominator for 3 and 5. We already know that's 15 from the last one, so let's boogie through these steps. I need to multiply the 3 by 5 and the 1 by 5 to get 5 over 15. I need to multiply the 5 and the 4 in the second fraction by 3 to get 12 over 15. And now hopefully you now see what the problem is, because I need to go 5 minus 12. I'm going to get, technically I get a negative number, but we're not going to say over here 2 minus 1 is 1. We're not going to say 1 and negative 7/15. That is not a correct way to express a mixed number. So when you run into this problem, you're actually going to need to borrow from the whole numbers over into the fractions. And like I said, in my opinion, this just becomes not worth it, not worth the time. It's easier to go to improper fractions when this happens. Let's go back to my question. Why did this happen? Answer is simple. The first fraction is smaller than the second fraction, which hopefully you could spot over here, because you know that if I tell you that that you ate a third of a pizza and I ate 4/5 of a pizza, who ate more pizza? I did, right? I don't know if you've noticed, but in every single example, I always get more pizza than you do. So a third is smaller than 4/5. Therefore, in this subtraction, you're going to run into this borrowing issue. It never happens with addition. With addition, sometimes you add up and get more than a whole, and then you just do the mixed number thing like we did earlier, and it's not a big deal. If the first fraction is bigger than the second fraction, not a problem. But when that second fraction is bigger than the first, you're going to run into this issue, which is why I would recommend instead doing the improper fraction version we did in the last slide. But let's just walk this through so you can see. So to do this subtraction, we need to borrow. Where are we going to borrow from? We're going to borrow from the whole number. We're going to take 1 away from that too. And we're going to add into the fraction. Now, when we're in 15ths, what is 1 whole? It is 15 over 15. So we're going to borrow 1 from here and add the 1 back in over here in the form of 15/15. So when I borrow 1 from 2, it becomes 1. When I add the 15/15 into 5/15, I get 5 plus 15 is 20. If you're starting to lose the path here and aren't sure about this, don't worry. That's why I recommend not doing it this way. I would go back and I would turn these into improper fractions, much easier in this case. But let's finish it anyways. So we borrowed 1 from the whole numbers. We've added that 1 back in on the fractions. And now you can see everything's all good. 1 minus 1 for the whole numbers is 0. And 20/15 minus 12/15. 20 minus 12 is 8, so 8/15. So we have 0 and 8/15, which of course we would just write 8/15, which is indeed the same number that we got before, just with a bit more hassle. And that is the end of our lesson on adding and subtracting fractions when they do not have a comma.